Hello, everyone from sunny Phoenix, Arizona. This is my official submission video for the Oyster Hackathon. For my project, what I've decided to present to you today is a um, machine learning project that takes the chats that have occurred on our website and attempts to predict whether or not they have sales value or not. And in order to do that, I've retrieved the source data that we have today of the chats that we have today, um, categorized those conversations into either sales qualified or not, just based off of the text that was available to me um, inside of that file, and have run it through this this data pre-processing um, scripting inside of a Jupyter notebook using Python 3 in a Conda environment, and ultimately developed five machine learning or put to use five different machine learning algorithms that all make a prediction on two common types of text that you see and ultimately make a prediction, right? So I'm going to run you through the code now quickly and get you to the output as soon as possible. So like I said, you're looking at a Jupyter notebook here that's operating on using Python 3, using some common packages like pandas, sklearn, and some natural language packages as well. So in a quick rundown, you're seeing packages uploaded here. A quick look at the distribution of the flagging here, or you could call these the labels of the data. So we have 214 that weren't flagged as sales qualified, 74 chats that were flagged as sales qualified. So the first thing that I wanted to do was to get this distribution a little bit more normalized, closer together. So I've got some language here. This is something that programmatically you'd want to probably create some type of feature for so that you can repeat it. But essentially, just to make it quick, I've gotten rid of 120 rows. The 120 rows uh, that had the least word count in the not flagged category. So sorted by total word count there. And so what you're left with are 94 not flagged records and 74 flagged records. So from there, we're going to go and just separate out our labels and do some data pre-processing here. So inside of this one line here, what we're doing is we're stripping out white space, converting it all to lowercase, and then getting rid of punctuation and numbers. And you can see just a quick look at what that data looks like here. The next step is to tokenize each one of those words individually in each one of those sentences in order to prepare for the next step, which is word stemming. And in this word stemming, what we're going to do is get the word down to its root. So this removes things like INGs, or it gets the word, words that are used in different ways down to their root. That way you can get a true count of the word itself. We'll then detokenize those for preparation for our next couple of steps, which is to split our data into training and test data sets. And now we're actually going to vectorize it. So the vectorizer that I determined to use for this is just a count vectorizer. So essentially this just uses the straight up count of the words. You can also use different vectorizers that prioritize the uniqueness of the word in the document. I've just through the modeling that I've done in here, the count vectorizer seems to work the best. So now we're actually going to take a look at these different models that we've assembled. So the first one is a random forest classifier. And for the sake of this video, I'm going to keep it I'm not going to explain how each one of these models work, but essentially I've chosen a few different types of algorithms. Some are decision trees, some are uh, mathematical models like logistic regression. So each one of these models takes in our training set and our test set and ultimately spits out a prediction at the end here, a test result. So you can see here that the overall accuracy for our model here was 64%. And then you can get into the individual metrics here for each one of these different types of labels. And each one of these precision, recall, and F1 score all have their own unique look at this data. So for example, recall would be, I believe it's the true positives that you found divided by the true positives plus false positives. So that's what you're kind of looking at here, and each one of these is unique, and you can use it to fine tune what you're looking at. So I've got random forest classifiers, naive Bayes, um, a decision tree classifier similar to random forest, k-nearest neighbors classifier, and all of these are spitting out, close to 60% accuracy. And the final one is logistic regression, which through my research has been kind of touted as one of the better ones for this type of modeling. So down here, I've actually created just a quick text column here, or text here, that takes our models that we've created. Each individual model runs a predict using a sentence that I've chosen. So this one would be, I'm looking to hire contractors. So very straightforward, right? And you can see here that the random forest algorithm has determined that this is flagged. Naive Bayes determined it's flagged. Decision tree determined that it's not flagged. Nearest neighbor determined that it's not flagged. Logistic regression determined that it is flagged. So I don't think it's uncommon for ensembles of models to be used in order to ultimately determine a decision at the end. So here we would probably be determining that this is indeed flaggable. And then exactly the opposite. I tried to choose a sentence that uses things like hired, uh, and I've actually got a misspelling here. So yeah, flag, flag, not flag, not flag, flag, not flag, not flag, not flag, not flag, flag. So there you go. So this is how we can put these algorithms to work for us using on our chatbot.